Hello everyone, good day. Welcome to the online distance learning class for subject Advanced Structural Steel Design, ECS571. Today we will learn a new topic, that is design of composite steel structures. At the end of this lecture, students should 1. Be able to identify the advantages of composite construction CO2-PO3. 2. Be able to explain the differences between prop and UN-propped composite construction CO2-PO3. 3. Be able to discuss the role of shear stud in composite beam CO2-PO3. 4. Be able to analyze and design a composite beam using universal beam sections CO1-PO2, CO2-PO3. 5. Be able to analyze and design a composite truss CO1-PO2, CO2-PO3. 6. Be able to analyze and design a composite plate girder CO1-PO2, CO2-PO3. Here are the course outcomes and program outcomes. Composite beams are universal beam, which have a reinforced concrete slab cast, such that shear forces can be transferred between the universal beam and the slab. Composite means that the steel structure is fixed to the concrete structure of the deck, so that the steel and concrete act together, so reducing deflections and increasing strength. This is done using shear connectors fixed to the steel beams and then embedded in the concrete. Shear connectors can be welded on, perhaps using a stud welder, or better still on export work, by fixing nuts and bolts. The shear forces are generally transferred by the use of headed shear studs, or stud connectors. Metal decks are often used to provide the firm work necessary to cast the concrete. In lieu of metal decks, precast slabs are also be used. Composite construction can also be used with plate girders as well as other types of steel structures, such as with steel trusses. This figure shows the behavior of composite truss girder, in which the top of the truss will experience compression, while the bottom part will experience tension. This figure shows the cross-section of the composite beam. Design of composite beams are covered by BSEN 1994 Part 1.1 Design of composite steel and concrete structures. However, only simply supported beams are discussed here. OK class, what is the advantages of composite construction? In general, a composite floor represents an outstanding efficient use of materials, providing quick, cost-effective and sustainable construction. Composite construction is robust and does not require tight tolerances, making the system quick to construct. A composite floor system has a low self-weight, which has a direct impact on the vertical structure and foundation size. Apart from that, the composite beams have higher stiffness than that of universal beam alone. The composite beams have higher bending capacity than that of universal beam alone. The composite construction is very fast, especially if metal deck is used as firmwork for casting floor slab. There are two types of composite constructions method, namely propped and UN-propped composite construction. In propped construction, the beam is temporarily supported by props during the casting and curing of the concrete slab. In UN-propped construction, the beam is not supported. This picture shows example of propped composite construction. In the propped method, the prefabricated units remain supported on the props, even during the laying as well as curing of cast in situ concrete. Hence, when the props are removed, the whole unit, that is, prefabricated in the cast in situ unit, will act as a monolithic unit strong enough to carry the dead load and the live load. This picture shows example of UN-propped composite construction. In the unpropped method, The prefabricated units are made strong enough to support the dead load of wet concrete and any constructional live load and load due to accidental formwork. However, disadvantages of UN-propped construction compared to propped construction. I-beam must be checked as a non-composite beam during construction to ensure that it can carry the concrete self-weight in addition to the construction loads. 2. The deflection at service is greater than that of a propped beam. 3. Generally have a less favorable stress state during service loads. At ultimate load, the capacity of the composite beam is the same whether propped or UN-propped construction techniques are used. UN-propped construction is more commonly used than propped construction due to speed and economic reasons. At ultimate load, the capacity of the composite beam is the same whether propped or UN-propped construction techniques are used. UN-propped construction is more commonly used than propped construction due to speed and economic reasons.